After this video of motion in a straight line, you all will be able to learn about kinematics, frame of reference, object in motion and its types, motion in 1, 2 or 3 dimensions, path length, distance and displacement, scalars and vectors, and at the last but not the least, uniform, variable and average speed and velocity. First, let's see what is kinematics. Kinematics deals with the study of motion of material objects without taking into account the factors like nature of forces, nature of bodies, etc., which cause motion. In kinematics, time factor plays an essential role. The term kinematics is derived from a Greek word kinema, which means motion. Now let's talk about the object at rest. An object is said to be at rest if it does not change its position with time and with respect to its surroundings. For example, a book lying on a table, a person sitting on a chair. These both are the examples of rest. Now, let's see the objects in motion. An object is said to be in motion if it changes its position with time and with respect to its surroundings. For example, a bird flying in air, a train moving on rails, a ship sailing on water, a man walking on road are some examples of motion visible to the eye. Motion of gas molecules is an example of motion which is invisible to the eye. Now, there are 3 main types of motion of a body. Let's see. The first is rectilinear, or we can say translatory motion. Rectilinear motion is that motion in which a particle or point mass body is moving along a straight line. Rectilinear or translatory motion can be uniform or non-uniform. For example, a body slipping along the inclined plane. Second, circular or rotatory motion. A circular motion is that motion in which a particle or a point mass body is moving on a circle. Circular or rotatory motion can be 2-dimensional or 3-dimensional motion, and they can be uniform or non-uniform motion. Oscillatory or vibratory motion. Oscillatory motion is that motion in which a body moves to and fro or back and forth repeatedly about a fixed point called mean position in a definite interval of time. In such a motion, the body is confined within well-defined limits on either side of mean position. It means a periodic and bounded motion of a body about a fixed point is called an oscillatory motion. For example, the motion of the pendulum of wall clock is oscillatory motion. Now, another subtopic is frame of reference. Let's see what is it. The frame of reference is a system of coordinate axes attached to an observer having a clock with him, with respect to which the observer can describe position, displacement, acceleration, etc. of a moving object. Now here there are two types of frame of reference. First, initial frame of reference. Second, non-inertial frame of reference. Inertial frame of reference is one in which Newton's first laws of motions holds good. For example, a frame of reference attached to a person in a bus at rest or moving with a uniform velocity along a straight path. Non-inertial frame of reference is one in which Newton's first law of motion does not hold good. For example, a frame of reference attached to a person in a bus moving with a variable velocity or moving with acceleration along a straight path. Now, the motion occurs in three dimensions. The first one is one-dimensional motion. The motion of an object is said to be one-dimensional motion if only one out of the three coordinates specifying the position of the object changes with respect to time. In one-dimensional motion, the object moves along a straight line or a well-defined straight path. Therefore, one-dimensional motion is sometimes known as rectilinear or linear motion. For example, the motion of a train along a straight railway track, a man walking on a level and narrow road. Now let's talk about the second or two-dimensional motion. The motion of an object is said to be two-dimensional motion if two out of the three coordinates specifying the position of the object changes with respect to time. In two-dimensional motion, the object moves in a plane. For example, an insect crawling on the wall, the earth revolving around the sun, a billiard ball moving over the billiard table. Now let's talk about the third and three-dimensional motion. The motion of an object is said to be three-dimensional motion if all the three coordinates specifying the position of an object changes with respect to time. In three-dimensional motion, the object moves in a space. For example, a kite flying on a windy day, a flying aeroplane, or a flying bird. Now, there are two types of quantities. The first one is scalar quantity and the second one is vector quantity. The physical quantities which have only magnitude but no direction are called scalar quantities or scalars. Mass, length, time, distance covered, speed, temperature, work, etc. are the few examples of scalars. The scalars can be added, subtracted, multiplied, and divided by ordinary laws of algebra. A scalar is specified by a mere number and unit, where number represents its magnitude. A scalar may be positive or negative. A scalar can be represented by a single letter. The physical quantities which have magnitude as well as direction are called vector quantities, or we can simply say vectors. Few examples of vectors are displacement, velocity, acceleration, force, gravitational intensity, etc. It is important to note that the division of a vector by another vector is not a valid operation in a vector algebra, because the division of a vector by a direction is not possible. A vector can be represented either by a single letter in boldface or by a single letter with an arrowhead on it. Now, let's talk about path length. The path length of an object in motion in a given time is the length of actual path traversed by the object in the given time. Or we can simply say the path length is the actual distance traveled by the object in the given time during motion. Path length has only magnitude and no direction. That is, path length is a scalar quantity. The value of path length, that is, distance traveled in a given time by an object in motion, can never be zero or negative. And now let's talk about displacement. The displacement of an object in motion in a given time is defined as the change in position of the object, that is, the difference between the final and the initial positions of the object in a given time. Displacement is the shortest distance between the two positions of the object, and its direction is from initial to final position of the object during the given interval of time. It is represented by the vector drawn from the initial position to its final position. Displacement is a vector quantity as it possesses both the magnitude and as well as direction. And now let's see the difference between distance and displacement. Distance is the actual path covered by the object in the given time, while displacement is the shortened distance between the initial and final positions of the object in the given time. Distance is a scalar quantity, that is, it has only magnitude but no direction, while displacement is a vector quantity, that is, it has both magnitude and as well as direction. The distance travelled can never be negative or zero, but it is always positive, while displacement of an object can be positive, zero, or negative. Now let's see what is speed. Speed of an object in motion is defined as the ratio of total path length, that is, actual distance covered, and the corresponding time taken by the object, that is, speed equals distance travelled upon time taken. Speed of an object in motion is a scalar quantity. Speed gives no idea about the direction of motion of the object. The speed of the object can be zero or positive, but never be negative. The SI unit of speed in CGS system is centimeter per second, and in MKS system it is meter per second. The dimensional formula of speed is m0 L1 t minus 1. Uniform speed. An object is said to be moving with a uniform speed if it covers equal distances in equal interval of time, however small these intervals may be. Let's try to explain it to you with an example. If a car is moving on a straight road from place A to B, distance 80 km in 4 hours, and covers 20 km in every 1 hour, then the car is moving with a uniform speed of 20 km per hour. Variable speed. An object is said to be moving with a variable speed if it covers equal distances in unequal intervals of time, or unequal distances in equal interval of time, howsoever small these intervals may be. Let's try to explain it to you with an example. If a car is moving on a straight road from place A to B and covers successive 20 km distances in timings 1.5 hour, 1.25 hour, 1 hour and 0.75 hour, the speed of the car at different locations is different, or is the speed of the car is varying. Now the car is said to be moving with a variable speed. And now we talk about average speed. When an object is moving with a variable speed, then the average speed of the object is that constant speed with which the object covers the same distance in a given time as it does while moving with variable speed during the given time. Or we can simply say average speed for the given motion is defined as the ratio of total distance traveled by the object to the total time taken. That is, average speed equals total distance traveled upon total time taken. Instantaneous speed. When the speed of an object is variable, then the object possesses different speed at different instants. The speed of an object at a given instant of time is called its instantaneous speed. Or we can simply say instantaneous speed of an object at an instant of time t is defined as the limit of the average speed as the time interval delta t at the given instant of time becomes infinitesimally small. Let at an instant of time t, an object while moving covers a distance delta s in a small interval of time delta t around time t, so that delta t equals 0. Then instantaneous speed equals ds upon dt. Now let's see what is velocity. Velocity of an object in motion is defined as the ratio of displacement and the corresponding time interval taken by the object. That is, velocity equals displacement covered upon time interval. Velocity is a vector quantity as it has both the magnitude as well as the direction. The velocity of an object can be positive, 0 and negative according as its displacement is positive, 0 or negative. The SI unit of velocity in CGS system is centimeter per second and in MKS system is meter per second. The dimensional formula of velocity is m0 L1 t minus 1. An object is said to be in uniform motion if its velocity is uniform and constant throughout the motion. That is, the object is moving with uniform velocity. Now, there's a question for you, which is, a man walks for 1 minute at a speed of 1 meter per second and then runs for 1 minute at a speed of 3 meter per second along a straight track. What is the average speed of the man? Please pause the video and try to solve the question, or you can say numerical. Now, please check your answer, and if you didn't get the solution, you can see it from here. Now, there's again a question for you guys, which is, a particle moves along a circle of radius r as given in the diagram. It starts from A and moves in anti-clockwise direction. Calculate the distance traveled by the particle. Now, there are 4 parts. First, from A to B. Second, from A to C. Third, from A to D. And fourth, in complete 1 revolution. Also calculate the magnitude of displacement in each case. If you didn't know how to solve the question, you can see it from here and try to understand, as we had to find the distance and displacement traveled. Thank you guys for watching this video. Please do not forget to like, share and hit the subscribe button and comment in the comment box. If you have any query regarding the motion in a straight line part 1, you can comment in the comment box and I will reply as quickly as I can.